Hi and welcome. This time around I have a project where I was restoring this Speed air dryer for air compressor for the shop. It came from a friend of mine's father who passed, and he didn't need it anymore. It was full of leaves and strange stuff, so I guess it was stored outside. So I cleaned it out. It needs a new water drain hose. It's got to come out here, and some new fittings on the in and out ports here. And it had some fittings, but I thought, you know, I could buy some fittings at the store, but why not try and make my own? So I'm going to try and do that. Before I do that, though, I have a little side project over on the lathe where I'm going to make these parts that I thought I'd do first. So I'm kind of sick and tired of constantly sweeping the chips out of these two T-slots here, so I thought, I'll get some T-slot covers. And there are some commercial ones out there, some made out of silicone, very, very expensive, some made out of aluminum I have over on the mill. They work fine. They're also fairly expensive. But I thought, you know, if I want to block this T-slot from collecting chips, I also have on many occasions wanted to mount things on here, and why not just make giant T-slot nuts that'll fit the entire length of these things. It'll keep the chips out when I'm not using it, and then I can always drill and tap holes for when I want to use it. So that's what I'm going to do first. That's my first side project. First up, a visit to the bandsaw. This is some 1018 mild steel. The material dimensions are pretty close to the T-slot dimensions, so that should be pretty good. A hardenable steel might have been better so that I could heat treat it and make the thread stronger, but I don't think this will be used all that often, so I didn't opt to go that route. Maybe that'll be a mistake. I can always remake this in the future if need be. Surface feet per minute is set at 300 for 1018 mild steel. Which kind of makes cutting this kind of like butter. This is 3/4 inch thick by 1 1/4 inch material. And you can see how quickly it goes through it. No issues at all. I'm very happy with this bandsaw. I have 2 of these to make, and I'm just going to square up the stock. I'm not going to be super precise about it because these are just T-slot nuts and just sort of a test idea right now. So that we're just going that route. Got about 1/4 inch of material to take off the thickness here. So rather than use the face mill, which really doesn't like big bites, at least on this lack of rigidity manual machine, I've switched to a coarse end mill, and we're taking out 210 thousandths pass. It's not quite wide enough to do the whole thing, so I'm doing a little over half. And we'll come back and finish the other half, and then I'll pop this piece in, do the exact same thing, and then we'll get a finishing end mill and do the final thickness. I'm just going to drill and tap for 1/2 inch 13 studs in 2 locations, and these will actually be the set screws that are going to hold this in place. And if you're wondering why I didn't stop and countersink these, because I've got a hand countersinker that I use on my Bosch drill with this bit here. This whole operation sped up a lot by using the Lipton style stop that I put on here. If you're wondering about this, I made it in a video a while ago. This is from a tool, a lathe cutting tool, ground on both sides with a spring Belleville washer on this side to press it up against the side of this. Works really well, and it's reproducible to around 1,000th, so that's plenty good for my needs. So I'm using the tapping machine here with a regular hand tap, which is not advised. This is neither a spiral flute or a spiral point. It's just a regular hand tap. There's a significant amount of force. There's the torque brake releasing. And what I do is I clean all the chips out and then go in again, and it seems to clear. On the next round, I have a spiral flute tap, and I'm going to try that. But I'm going to finish it with this one, and I'll show you the next one. Here is a spiral flute tap, which ejects the chips upwards. They're weaker, so I've got concerns that it's going to break, but no, it works a lot better. I guess the moral of the story is don't use a hand tap in a power tap machine because it's not suited for it. doesn't eject chips properly or something like that, because cleaning the chips off makes it work great. So there we go. That's the first one. One more to go and we're all done. All right, so these set screws right now are just to hold these in place so they don't slide around on the lathe. However, interesting to note is that I chose 1/2" 13 because that's the size of the stud set from my mill. So if I want to clamp something down using the clamps on the mill, I've got 1/2" 13 threads all ready to go, and that's why I chose them. They should work pretty well. And I've got soft bottom nylon bottom bits so that it doesn't scratch the bottom of the T-slot. I don't know how big a deal that is, so rather than risk it, I just went for it. Steel would definitely mar up the bottom and put potential burrs in there, so we went with this instead. Alrighty, over to the lathe. Alright, so with the cross slide all the way back, I can slide these guys in. And then to keep them in place so they don't pop out, just tighten these set screws. So the set screws themselves are going to get full of goop, I'm sure. But we can blow those out before we remove these if we need to do that. And if I need to drill additional holes and tap for mounting something here, I can also do that. I could have done a better job on rounding off these corners. I did it by hand, and anything that requires hand-eye coordination is a little tough. This one's pretty good. This one, I got one little ding in there where it flattened out, and I'm not so happy with that. But I'll get better. Anyways, all right, so back on the air dryer project. These pipes have some weird fittings, some swage fittings on them. And that's not so terribly common for compressors, although I do see it in plumbing situations. But in any case, I'm going to remove these guys and I'm going to braze on some fittings of my own. That way I don't have to worry about dealing with this. I'm thinking about making right-handed fittings, even though air going around a corner adds friction and lowers your flow rate, but hopefully that won't be too much. Also, there's something jammed up the center of these. I'm guessing it's some sort of filter material or something, but I don't know, whatever it is, it's flaky and disintegrating, so we're going to remove that too. So we're going to cut off these ends here as close to the, the good parts as I can, and we'll see about making our own. Originally, I was going to go to the store and buy them, and I thought, hey, I can make these. Speaking about making my own, I chose these two connectors from my compressor. They're both males, which means I need to make female adapters to the pipe. I could have just as easily gone the other direction. I'm sure most people are very familiar with NPT pipe taps. It would be really handy if they put the tap drill size on it, but I was able to find that in the Machinery's Handbook and some online sources. I also did not actually consider, but there is the possibility you can do female threads on this side, male threads on whatever part you're making, and I didn't even think about this. I mean, you could always do a taper attachment if you had one on your lathe, or use your, you can't use your compound, so you'd have to turn off center. Taking your part of the lathe and shift your tailstock over so you could turn this taper. I don't think too many people are going to want to thread that way. I've never tried it, but setting up your tailstock is a real pain. But they do make dies for all the standard pipe size, which is really handy. So that's also an option. I got this kit off Amazon. It seems like it's okay quality. Kymex is the name on it. It was fairly inexpensive, and since it's something I'm not planning on doing all the time, I didn't buy a really nice set, but here's another option for you. These should be fairly straightforward, but I'd like to point out I've never made anything like this before, so that's one of the reasons I'm trying it, because it's interesting. Starting with hex stock, that way I can use a wrench to hold this while I tighten the NPT fitting on, so that saves you a lot of trouble down the line. They sell it in standard sizes, so why not take advantage of it? Brass is wonderful stuff to work with, but it gets all over the place. And that is why I'll be taking advantage of the inserts here to keep the brass particles out of the T-slots, just make it that much easier to clean up when I'm done. These parts should be really straightforward. First, I'm going to through drill. I've decided to make these straight parts because I don't think there's enough meat in the side of this to make an angle. Well, could I? Oh, yeah. So one of the things I want to do is on the other side of this, the NPT side is going to be over here. So I'm going to drill and tap for the NPT side. The other side, I want to reduce the diameter so that it'll be easier to braze on. So that's why I'm not going to do a right angled part, because otherwise that would be, there's not enough material here to easily turn down a spot where I could reduce the diameter of the material. Before I move on, I should chamfer this. Actually, I think I'll use an end mill. I was going to use the 7/16 drill bit, but I have a 7/16 end mill, and I do need a flat bottom. Well, I would like a flat bottom on it, so let's use it. Thought I'd get some chatter, but actually that worked pretty well. All right, so we're going to tap this guy. Got a piece of brass here where the tap handle touches my cross slide because I don't want to scratch it unnecessarily. Put this guy in neutral, and what I can do is I can use the chuck key to do this. I'm not sure how deep to go because it's tapered, so you want it to run out of threads before the coupler does so that they'll pull tight. I guess let's try there for starters. I am honestly not sure, having never done this before. You can see that if you go in too deep with the threads, you'll have a problem because you'll run out of threads. Oh, this tightens up immediately. Okay, so I don't think this one's going to be a problem. Wow, that tightened up quickly. Makes me wonder if I should go in further. Because that only caught the outside couple. Well, since this is just a test anyways, let's see if we can bottom out the 6/10 of an inch area. See what that yields us. Ooh, that's tight. Okay, that must be it already. It goes in easy about half the thread distance. It seems to me like maybe I'd want to be a little further, so maybe it should be drilled in a little further than 0.6. Because it's catching only about that much in the way of threads. I think 3 threads would probably be enough, but yeah, let's try a little deeper hole. All right, so we're going to go for a bit of a deeper hole. Another 150 thousandths, we'll go to 0.75. See if that makes a difference. Gives me a few more threads to engage with there. So we're going just a little bit deeper now. And you gotta know with taper taps, they're cutting along their entire length because it's bigger on this end, smaller on that end. So as this goes in, I gotta cut the entire length. So there's a fair amount of force, although it's not excessive, I gotta say. Okay, that eats up my extra 150 thousandths. Oh, there we go. I like that better. So 750 thousandths it is. That'll get 3/4 of the thread depth, and then I can tighten more with the wrench. I think it should be just right. All right, so I just reduced a little material here for appearance's sake, just to see what it would look like. I think it looks a little better, a little less chunky. Then we're gonna part this guy off, reduce the rear, flip it around, reduce the rear diameter so that I don't have to braze such a thick amount of material on there, and we should be good to go. And then I have to counter drill for 3/8, which is the diameter of the copper pipe. Just need to part this guy off. Didn't even make the hole all the way through it. Oops. Should have kept going there. There we go. Before I flip the other part around, I might as well go ahead and make the other one since I need to make 2 of these. I finished the second one, flipped it around. This one, the hole went all the way through because I made sure. And we're going to shoot for a final diameter of 0.625. This should leave an 1/8 inch of material aside when I'm done. Not a lot of meat to hold on. I might want to switch to a 5C collet because I can't get in there. Nope. So we're going to go in 4/10 of an inch. Then I can reevaluate how chunky this looks. I think it looks chunky. We might go in farther. We might remove more off the outside. So there's my part. I think I could drill that center hole a little bit larger. I wanted to stop for the 3/8, so I might grab a 5/16 drill bit and at least drill that bigger. That way they'll get better airflow through it. Why limit it? Although the 3/8 inch tubing I think is barely 1/4 inch on the inside anyways. It's thick walled tubing. Guess we'll go with a 5/16 drill bit. That'll leave a 1/16, well, 32nd aside to stop the tubing from going in all the way. There we go. And so we'll let a lot more airflow, potentially. I checked the tubing and the tubing actually has a little bit larger than 3/4 inch, so seems like a reasonable approach. And now that should finish one of these, and we'll do the next one. There you can see the center hole's bigger now, let more airflow through, but there's still a lip in there if you can catch it in the light. That'll stop the 3/8 inch tubing from going in too deep, and we should be good. These are going to stick out quite a ways. I'm a little annoyed by that. A right angle might be better because these are going to point straight out, but I think for my application it'll be okay. So you can see already how much easier that is. I have brass in the Allen head screws, but I could blow that out at some point. But constantly having to get in there and clean out all of those T-slots was miserable. All right, so we're just gonna add a little bit of flux here on the ends of these copper tubing. I've already sanded them, and we'll braze on the fittings. This first fitting, I think the brass is such a big chunk of metal that I need to heat it a long time, and I actually overheat it before I try and add the silver solder, and it doesn't work as well because the flux burns off. So I know my hand's in the way here, but the silver solder is not really wetting the material very well. It's just beating up and falling off, which is no good. If you get the flux right and it's sanded right, it'll wet nicely, and this was not that case. So I'm just cleaning them off here. The second one, it only took heat for like maybe 30 seconds, and it wetted perfectly. The first one I had to clean up and add more flux, and anyways, it's a nice airtight seal, and we should be good to go. So I'm going to throw a couple fittings on here, and you'll see in short order why I use the hex stock, because you want to be able to support tightening that fitting on, because otherwise all that force goes on the copper tubing, and you could damage the copper tubing, especially in cases where it's smaller. But this is even thick-walled tubing. It gives a fair amount, so you wouldn't want to put that force there. Just put the female on the outlet side and we'll be good to go. There's still a bit of bending even though I'm supporting tightening it. As you can see, you wouldn't want to just reef on that all by itself. Next up, we'll go for a leak test and make sure it's all soldered adequately, and sure enough, yep, it is. And we're hearing some, which you can't because the microphone failed. You're hearing some hissing sound. That's actually air leaking out of the water separator. The valve in the bottom of the water separator is no good. All right, so if you're wondering where the leak's coming from, the leak is coming from the water separation portion of this. That's the drain right there. So the valve's probably gone bad in that, or maybe they mean to always have a little airflow. I don't think so. I think the valve's gone bad. However, that's designed to work. The air goes in here, goes around the coil a bunch of times, comes back out here, but at the bottom they tap off to get the water to collect the water. There's refrigeration section in the middle here. This section is refrigerated, and that cools the water off to allow the air to flow out. But bottom line is, I think this whole project was a success because the whole point was to make these fittings, and now I know I can make MPT fittings, and that's really good to know because I've always been at the mercy of what the hardware store had in stock or didn't have in stock, and now I know I can make them myself, and these only took like 45 minutes, and they take less next time because I know how to do it now. So this is a straight design. I was going to do a perpendicular design where I came in from the side, but I decided that I wouldn't have enough meat, plus I'd have to heat the whole part up. Turns out these things heat really quickly. I overheated the first one, so that was part of the problem. I could have got the silver to flow much sooner, and that was my mistake because I haven't done it in a very long time. But it could have gone in the side, or I could take a square block and then get to come inside to make a proper 90. But in any case, this worked and worked very successfully. It doesn't leak, and that's what's important. And I know that I can make them myself now if I need to. This thing, however, is very old. I don't know if there are any parts for it anymore, so we'll have to see if there's anything we can even do to fix this. But again, primary objective was met, trying to make those connections, and I think that's very good. Plus I got those way covers, the T-slot covers on my lathe. That was also very successful. Thanks for watching. Hope you find it useful. Hope to see you next time.